Okay, in this video, let's talk about these alpha cleavage reactions in photochemistry, right? So we have talked lot of topics in photochemistry, right? In our previous video, if you remember, we have talked about these carbonyl groups, otherwise these carbonyl structures, how to identify the particular transitions, whether it's pi to pi star or n to pi star. I hope you remember it. If you want to go through it, I will put the link here. I highly recommend you to watch it because here we are continuing our discussion about the photochemistry, right? So in this video, we are going to talk about the alpha cleavage reactions in photochemistry. Now, if you remember, the reactions based on the photochemistry mostly involved with the radical mechanisms, right? So in here also we are going to focus more about the radical mechanisms or otherwise radical reactions. First of all, let me introduce you to this alpha cleavage part. What is this alpha cleavage means? Let me introduce you to the if I take an example molecule like this, okay, you know, this is an aldehyde, sorry, not aldehyde, it's a ketone. So here we have the carbonyl carbon. Now first what I want you to do is identify these carbons, right? I hope you know this carbon is the carbonyl carbon, right? This is the carbonyl carbon. It's pretty much famous. And these two carbons over here, I hope you know these are the alpha carbons. Now the alpha cleavage means the cleavage of this carbonyl carbon and this alpha carbon. So there are two possibilities, right? Either breakage can happen on this position or this position. Both are possible, right? So most of the cases when you look at the alpha cleavage reactions, there can be several products because there are two possibilities to the cleavage. Now let's move on to see like how this cleavage happens. If you remember, we have talked about this excitation in our early videos. I hope you are okay with the excitations now. First thing, otherwise when you talk about the photochemistry, the first step that happens inside the reaction mechanism is the excitation. So here we have the ground state molecule. Here this molecule is in the singlet ground state. Always mention the energy state, right? That would give you much more detailed answer. When the examiner sees your answer, it would be much like, how can I say that, it would be much more professional, right? So always state the energy state. Now what happens there is first, now what happens is the excitation. Here we have the molecule. Now this molecule is excited. Now this excitation can happen either S1, which is the singlet excited state, and you need to mention the transition, right? As you can see, there are no pi bonds here, so this is not a pi to pi star transition. There are no pi to pi star transitions would happen. So we have talked about how to choose the transition, otherwise how to identify this transition much more in detailed manner in our previous video. So that's why I have highly recommend you to watch that video. If you have no idea about how to identify the transition, then you have to watch it, right? So here you can see there are only carbonyl group. There's only one chromophore, so it should be n to pi star transition. And this is not the only transition, sorry, this is not the only excited state we have. There's another excited state. So we can either have T1 excited state, right? It's also n to pi star transition. This is the triplet state. Now next thing is there are two possibilities, as I have mentioned you. Either the breakage can happen through here or breakage can happen through here. So what happens is these are radical mechanism. So this bond will break into a radicals. So here we have like this. Here we have a radical plus here we have a radical. This is the first possible way, right? This is the first possible products which we can obtain. And the next way, the second way, this bond can be broken. Here the same mechanism. I have drawn it in the red color, right? So here we have the second one. So here we have the methyl group CH3. Here we have the CH3 with the radical. So this radical electron should be there on the carbon. Okay, this is on the carbon, and here we have the other part. These are the two possibilities we have. So always remember this. Always remember that there are two possibilities for the alpha cleavage reaction. That's very important when you try to identify the mechanism, right? Yeah, so I have done a small mistake here. So there should be yeah, it's fine. This is CH2, right? This is CH2 and CH3. Just to make you sure. Okay. Here we have only CH3 part. That's why I have only one radical here. We call this type of cleavage as homolytic cleavage, if you remember. This is an homolytic cleavage. And after this cleavage happens, right? After this cleavage happens, there are several possibilities that these radicals can undergo. So let's talk about these things. First thing that can undergo is the decarbonization. Let me write it for you. Sorry. Right. Decarbonization. Now, in this case, what happens is, let's take these parts, right? Let's take this one. Here we have the products. Let me explain to you. Now, these are the two segments, or otherwise two radicals we had from our initial step. Okay, now what can happen is, okay, as you can see, there's another alpha bond over here. So this alpha bond can break again, right? This alpha bond can break again. Let me draw it in white color. Here, this alpha bond is going to break again. And here we have CH3 radical. And now we have carbon and oxygen. These two electrons are going to form another bond which releases carbon monoxide. Here we have the carbon monoxide, and this one here, it's like the same. Now these two can join together, right? These two can join together to form this final result. So this is the decarbonization process. Important thing you need to remember, otherwise you need to be very careful about, is the releasing of carbon monoxide. That's why we are calling as decarbonization. Your final product will remove the carbon monoxide group. Okay, the carbon monoxide group, or otherwise the carbonyl group in the structure. And now in the second part is the disprotonation, right, which means removal of the proton, right? So let me give you the example. So let's take the same segments as here. Here we have the radical, and the other product is this one. So let's put it like here. Here we have CH2 and a radical is there, and here we have CH2, and here we have the CH3, right? So I am going to put CH2 and another hydrogen here. Now here what happens is a proton will be released. Not a proton, right? It's a hydrogen radical like this, and this hydrogen will go and combine with our carbonate structure here. Now we have this one. This hydrogen is going along with here, and here you can see an alkene would form. An alkene is formed. This is the second type of reactions can get undergo, and the next one is the coupling reaction. It's pretty much easier, right? It's not a complex thing. The coupling means initially, as you remember here, the cleavage is happen, right? Cleavage is happen, and coupling means these two can get back together once again to form the initial structure. That's the coupling, right? So these are the three possible ways, or otherwise three possible mechanisms that can happen after the alpha cleavage. So you have to think about these three cases when you are trying to identify a particular reaction, otherwise particular mechanism. So let's do some examples and see how to arrive at the particular mechanisms. So first example I have chosen is this one. What you can say about this one? Here we have a structure like this, and I want the mechanism for the formation of the structure of this. Can you answer this question? Can you pause this video and try it for yourself, and I will do it then. So here, as you can see, there's a carbonyl structure here. Now what you need to know about is, when you have a carbonyl structure, first thing what happens is the excitation. So first let's do the excitation process. Here we have the excitation. This is the excited molecule, and you have to mention the energy state, which is a singlet excited state, and the transition n2 pi star. And next one is the triplet state, n2 pi star. And then a breakage can happen, right? Then the breakage can happen. You can see there are two alpha bonds or two position which we can introduce this alpha cleavage, either here or here. As you can see in the final structure, I hope you can see that we have to cleave this particular bond, right? So let's break this particular bond. I will break it in blue color. Now we have the structure like this. We have here, 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 right? So this is our structure. Now okay, now what can we introduce? So we have only three, right? We have only three processes after this cleavage. Either it's a decarboxylation, which is removal of the carbon monoxide, or otherwise disprotonation, which is the replacement of your hydrogen atoms. As you can see here, through a radical mechanism, hydrogen is replaced from one position to another. And the last one is the coupling reaction. So as you can see, the carbonyl part here, carbon and oxygen part is same, right? It's in the molecule, right? It's not being replaced, right? It's not being removed. So the first one is not the process which is undergoing around this particular reaction. And if you look at the coupling, right? Coupling means coming back to the original form. Otherwise, coupling means forming this bond once again. But that's not happens, right? The bond is broken. It's permanent. It's permanently broken, right? So only possibility is the replacement of the hydrogens. As you can see, there are no radicals around here, right? Which means there should be hydrogen here, right? So some cases the question paper will give you a hydrogen here. In some cases they will not give a hydrogen there, right? Some cases question paper will give you it like this. In that case, you need to identify there is a hydrogen here, because there is a carbon here. 1, 2, 3. There are 3 bonds which is attached to this carbon, and one is missing. That missing one should be either a radical electron or another bond. So here, if it's a radical electron, the question paper must provide that. This case there are no radical electrons, so there should be a bond there. So normally we do not show. It's not a normal thing, but sometimes we do not show hydrogen bonds, right? Carbon hydrogen bond, we do not show it sometimes. So you need to know there should be a hydrogen here. So displacement of hydrogen is being occurred in these particular reactions, right? So let's see. Here we have a hydrogen. So this bond is broken to form the alkene here, and this one is gone here to form this part one here. I hope you get the idea, right? So this is our final structure. It's a pretty much, it's not that much hard. I hope you get it. Let's do another quick example. So I will choose this structure. How about this one? This is little bit complex, but it's not a big deal, right? So when we apply the HU, otherwise when we apply the light, the photolysis can happen. So the final product would be like this. Okay, now the question is, we need to identify the mechanism for this particular reaction, right? So let's see how we can arrive at the answer. The first one should be the excitation process. You need to show the excitation. So let's do the excitation here. So this is the excited molecule. You need to mention the energy states, singlet excited states, which is occurring through N to pi star transition, or it can be a triplet excited state which is occurring through a N to pi star transition. Okay. Now in the second step, what happens is, you can see there's a carbonyl group here. You can see the carbonyl group here. Now if you see a carbonyl group, there should be a alpha cleavage bond breaking, right? Most cases, like when you, if you remember in our last video also, alpha cleavage is not the only reaction that happens around this chromophore. There are other reactions also, but when you look at these structures, right, when you look at these products, you can see that alpha cleavage is the one which has happened here. As you can see, this our carbonyl group is originally attached to our whole ring system here. Now in both cases, you can see our carbonyl carbon and this carbonyl group is separated from our original ring system, and hydrogen is attached to other part, which means the alpha cleavage has occurred. So in this case also, I'm thinking about alpha cleavage. Now there are two possible ways. First, let's go with this particular position, right? I'm going to break this bond. So here I'm going to break this bond. We have this one, and there's a radical here, and we have oxygen over here, right? And here have a radical here. Now what we can expect out from this product, right? So there are three possibilities, right? Either decarboxylation can happen, or that hydrogen can be replaced, or a coupling can happen, right? So as you can see here, our carbonyl group is in the same position. I mean, it's on the structure, right? It's not been removed. So first process is not happened here, and the initial coupling process, right? The coupling process is not happened either, right? So our products are completely different from the initial structure, which means the coupling has not occurred in this case. So only position is that hydrogen transfer. So in this case, you can see hydrogen transfer can happen through here. Here we have hydrogen. Alkene can happen from here, right? Or either the bond can be here. So we introduce this one to this one. Now if you look at this, right, if you look at this particular process, okay, if you look at this, you will see this is not the structure you are expecting out of the mechanism, right? As you can see here, look at this. If I number the carbons, 1 2 3 here, 1 2 3, okay. Now the double bond is occurring on this particular position here. If I use this hydrogen for our replacement option, right? So our double bond occurring in this particular position. So there are, after 3, there are 4 and 5. If I go through here also, 4 and 5. Always there's a one carbon gap. One carbon gap is there to meet the double bond, right? If I start from here, there are two paths available for me to go, right? So in order to meet the double bond, I need to pass another carbon. If I go through this way, I will meet this carbon, and then I will find the double bond. If I go through this way, I will meet this carbon and then find the double bond. But as you can see in our product, that's not the case, right? 1, 2, 3, and if I go through this way, the first carbon I meet, that's is the carbon which is formed with a double bond. So if I use this hydrogen to form my double bond, my initial structure, otherwise my final product is, I can't form my final product. So this is not the mechanism, otherwise this is not the way, this is not the path which we need to follow. So we have to change the hydrogen. As you can see, there are two possibilities, right? Here, this is the place where our radical is positioned, right? So double bond can happen through here. So this is the radical position, right? So double bond happen through either this way or this way. Now when I first go through this hydrogen, I can sense it that my product is not forming by removing this hydrogen to this place, right? There's a gap, gap in between carbon, right? So I chose that's not the path we need to follow, so I'm going to think about the other way. So instead of removing this hydrogen, I'm going to remove a hydrogen from here. Okay, here I'm going to remove a hydrogen from here. So here I'm going to remove this hydrogen, and now you can see we can obtain this product. 1, 2, 3. If I go through this way, right? If I go through this way, the double bond, right? The double bond is forming between this carbon and this carbon here in this position. So if I go through this way, the first carbon I meet, that's the carbon which is formed the double bond. Same like here, 1, 2, 3. The first carbon I meet, it forms the double bond, right? I hope you get the idea, right? That's very important. So this is the mechanism which forms with this product. Now there's another product, right? There's another product. So let me go through that also. So I will erase this one. So how to arrive at this other product, right? It's pretty much easy, right? So as I have told you earlier, we have two options initially to break the alpha bond. So initially we have two products. So in our one pathway, we have arrived at a particular answer. So the other pathway or the other answer, other product must be from the other pathway. So initially we have break this bond, and let's try to break this bond. Now when you break this bond, you will see that small packet is forming, small carbon packet, or otherwise this carbon chain. It's not a carbon chain, I mean small bump. How can I say that? This one, there's a CH3, otherwise there's a carbon which is popping out from your ring. If you break this ring, if you break this bond, right? When you break this bond, this carbon will popping out from your original ring. So that's what I am doing. Okay, here we have the original structure, and then here we have the oxygen, and now here we have our broken alpha cleaved product. Now there are three possibilities, right? Either we can remove the carbon monoxide part. As you can see, the carbon monoxide part is not being removed, so that's not the case. Either coupling can happen, but as you can see, the final product is not the same as our initial product, so coupling can't be happen. Only possibility is the replacement of the hydrogen. So here we have the radical, only possible way that the hydrogen can be removed through here. So here we can introduce the replacement of the hydrogen, so this hydrogen can form between this part. Here we have the structure. Now there is a double bond here, and we have the hydrogen structure here, same like here, right? If you grab this carbon, right? So if you grab this carbon and pull it out into this position, right? You grab this carbon and pull it out to this position, you will get the same structure, right? So here this is the 1, 2, 3, 4, 5, 6 and 7. 1 2 3 4 5 6. No, sorry, I just, sorry, that's not the case. Let me draw it again. Yeah, wait a minute, I will number the carbons so you can understand it very quickly, right? So here we have 1 and 2, and this is 6, right? Right, it's not the 6, no, this is the 6, this is the 6, and this is the 5, and this is the 4, and this is the 3, and this is the 7. This is the number system. Okay, 1 2 3, so 6 is around here, right? So you have to grab this 4 and put it here, 7 take it down and put it here, 5 take it here and put it here, right? You just need to reshape the structure. I hope you get the idea, right? I hope you can imagine the structure. You just need to stretch it out. This is the number system, this is the carbon positions of this particular structure. So this is about the alpha cleavage, right? This is how we can arrive at particular answer, like when you given the question and when you given the reaction, this is how we arrive for a particular mechanism. I hope you are okay with it. If you have any problems, feel free to comment below. I will try my best to answer your questions.